So go to new, then source file, and save it. Save as. So I'm going to save this new file in the folder macro. That's because my include.c is also present in this macro. So I'm going to name it anil. Then make sure that you have this save as type C source files. Save it. Now in this anil.c we're going to write a simple function. It's going to be void display, and it's not going to take any arguments. Here in this display function we want to print this is printed from a function which is in another file. So this is it. Save it. So now in our include.c we have to include this anil.c. That's why we're going to use this hash include. Then in the double quotes we're going to specify the file name. That's going to be anil.c. So now our include.c has successfully included this anil.c. Now what we have to do is we have to use the function specified in this anil.c. That's display. So I'm going to call that function in my main method. This is it. Save it, compile it, and run it. So as you can see here, this is printed from a function which is in another file. Close it. Now for the demonstration purpose, I'm going to change it to angle brackets here. So what happens here is, our preprocessor is not going to search for this anil.c in the folder where this include.c is present. So it's going to search for this file anil.c only in the folder which is specified here. That is C, UCPP, and include. But our anil.c is not present there. That's why it's going to give some error. I'm going to save it and compile it. So as you can see here, no such file or directory. We got an error. Now, the last thing I want to teach you here in this tutorial is we can use this double quotes here. What happens is, the preprocessor is going to search for this con.io.h file in the folder where this include.c is present. So when it finds that, okay, this con.io.h file is not present in this folder, then it's going to search for that file in the path we specified here. So save it, compile it, and run it. So as you can see here, there's no change in the output. Another thing is you can have a space, as many spaces you want here also. Okay, if you write a file name which is not present, then it's going to give the same error like, okay, the file is not found. Let's say anil.c, this file is not present. So as you can see, anil.c, no such file or directory. So make it anil. Okay, so this is it. This is about the hash include preprocessor directive. So thank you for watching, and don't forget to subscribe. I'll see you in the next tutorial. Hi, this is Anil back with another video tutorial for the Learning Lab on C programming. In this video tutorial, we're going to see the conditional compilation directives provided by the preprocessor in C. These are the directives that allow you to selectively compile portions of your program's source code. So the most commonly used directives are, hash if, hash else, hash elif, and hash endif. And another thing is, these are similar to if, else, and else if. So by using these directives, we can include portions of the code based upon the outcome of some constant expression. So let's see how we can use them in our program. For the demonstration purpose, in this tutorial, we're going to define an identifier called mark, and it's going to contain our mark. And by using this conditional compilation directives, we're going to check for some conditions by using the identifier mark, and then we're going to include some part of the code depending on the condition. So first define it. It's going to be hash define then mark, and I'm going to assign it to the value of 95. So here in this main function, we have to use these directives. First we're going to use this if. It's going to be hash if, then we have to write the expression, then it should end with end if. So make a note that we're not using any curly braces as we were using while using that if else. So here the code which is written between this if and end if will be the code that will be compiled if our condition here is executed successfully, or if our condition here evaluated to true. So here we're going to write our expression is going to be mark is greater than or equal to 75. If it is so, then we want to compile some code or include some code. It's going to be printf, and we're going to say your marks are greater than 75, and we're going to use another printf. You have got the grade A. So now if this expression is satisfied, then these two printf statements will be compiled. Otherwise these two statements are skipped. So we're going to save it, compile it, and run it. So as you can see, since this expression is evaluated to true, mark is greater than or equal to 75 here, our preprocessor included these two lines. So that's why we're getting your marks are greater than 75 and you have got a grade A. So this is about hash if directive. Now we're going to see hash else. So what if we want to compile or include some code if this condition fails? At that time we can use hash else. It's similar to the else condition in if. It's going to be printf your marks are less. Save it. Now we're going to make it less than 75. I'm going to make it 65. Save it. Now this expression will be evaluated to false. That's because now this mark is 65, which is not greater than or equal to 75. That's why these two statements will be skipped or not compiled. Only this printf statement in this else block will be compiled. So save it, compile, and run it. So as you can see, your marks are less. So this is about hash if and hash else. Now as you're going to see hash elif. This elif is similar to the else if. So here, if you want to test whether my marks are also greater than or equal to 50. Then it is so, then now if we want to compile some code, some other code, it's going to be hash and if, then we have to write the expression. It's going to be mark greater than or equal to 50. So now if our marks are greater than or equal to 50, we're going to copy this and paste it here, and we're going to say the marks are greater than 50 and less than 75, and we're going to say okay, you got a grade B. And in the else part, just for making it pretty, we're going to say you got the grade C. Save it. Our mark is 65, which is less than 75. That's why this expression evaluates to false. So these two lines will not be compiled or included, and this mark is greater than equal to 50 is evaluated to true. That's why we're going to compile these two lines. So and also these two lines are also being skipped. So save it, compile it, and run. So as you can see here, the marks are greater than 50 and less than 75, and you have got the grade B. So now just for the demonstration purpose, we're going to make it less than 50. Let's say 35. Save it, compile, and run. Your marks are less. You got the grade C. So let's make it 95. Compile and run. Okay, your marks are greater than 75, and you have got the grade A. So by using this conditional compilation directives, you can compile only the specific part of your source code. So if you're writing a large program and you're maintaining the versions, and depending on that version needed, if you have to compile the code, then you can use these directives. So this is it. This is about the conditional compilation directives in C. Thanks for watching, and don't forget to subscribe. I'll see you in the next tutorial. This is Anil with the video tutorial for the Learning Lad on C programming. In this video tutorial, we can see the conditional compilation statements like if and if and if. Then we're going to see the undif directive in C. The syntax of this if directive is here. So as you can see, if this macro name is defined by using hash define directive, then these statements will be added by the preprocessor in our expanded source code, so that the compiler is going to compile that code. So if this macro name is not defined by using the hash define directive, then this statement will not be added or included by our preprocessor, and in the expanded source code, these statements will not be there. So this statement will not be compiled by our compiler. So the syntax of this if and if is this one. Here it's just the complement of the if. So if this macro name is not defined by using hash define directive, then this statement will be added or included by our preprocessor in the expanded source code, and so that our compiler is going to compile that statement. So it's just a complement of this if. And the next thing is this undif. We use this undif to undefine any macros which are defined by using hash define directive. So we're going to see about that later. First we're going to begin with this if. Now for the demonstration purpose, we're going to define a macro by using hash define, and we're going to name it as Intel. So now in our main function, we're going to check whether if this macro is defined. So it's going to be hash if div Intel as a macro name. Then we want to execute some code within this if div and end div. So here we want to print something. Let's say course for the Intel PC. Save it, compile it, and run. So as you can see here, since this Intel macro is defined by using this hash define here, the code for the Intel PC will be included by our preprocessor in our expanded source code. That's why our compiler is going to compile that statement. Now we're going to close it. So now for the demonstration purpose, we're going to remove this line, save it, compile it, and run it. So as you can see here, nothing is printed. That's because this if resulted in false, or this Intel macro name is not defined. That's why this printf statement is skipped. So now we can use this if not defined. Now this Intel macro is not defined in our program using hash define. That's why this printf statement will be included. Actually, this Intel macro is not defined. That's why it's going to be for the non-Intel PC. So as you can see, the code for the non-Intel PC. And now we're going to define it. It's going to be hash define Intel. Now Intel macro name is defined. Now we can use this hash undif to undefine this macro. So now save it, compile it, and run it. So as you can see here, since this Intel macro is defined, this printf statement is skipped. Now we're going to close it, and we're going to use this hash undif and undefine this Intel macro name. Now save it. Now what happens is, first we are defining this Intel macro, and then we are undefining it. So when it comes to here, if and if Intel here, this Intel macro is not defined, that's because we have undefined it. That's why this printf statement will be included. So save it, compile it, and run it. So as you can see here, go for the non-Intel PC. So this is it. This is about the if diff, if and if, and undif. So thanks for watching, and don't forget to subscribe. I'll see you in the next tutorial. This is Anil with a video tutorial for the Learning Lab on C programming. In this video tutorial, we're going to see the files in C. Files are the building blocks of every operating system. So you can say that files are the virtual container to store some data. So in other tutorials, we have used variable to store data. So when our program terminated, then the value stored in that variable were lost. So if you want to save something in the memory permanently, then you can use files and store it. So let's see how we can use these files in C. So to use a file in C, first you have to open that file. So for that purpose, this stdio.h header file provides a function for you, and the function is called fopen. As a parameter to this fopen function, first we have to specify the file name that we want to open, then the mode at which we want to open. So this file name is the name of the file with the extension. So if you're opening a text file, then you have to specify file name.txt. If you're opening let's say .c file, then you have to specify file name.c. So then the mode is pretty much like what you want to do with that file. So if you want to open the file for reading, then you can specify this mode as R for reading. And make a note that you have to specify this mode in double quotes. So you can't specify this mode in single quotes. That's because this mode is a string value. Now, when this fopen function opens this file using this mode R, first it's going to search for that file. So if that file is present, then it's going to open that file for you. If that file is not present there, then it's going to return a null value. Then if you want to open the file for writing, then you have to specify this mode as W. So when you open this file with the mode W, this fopen is going to search for that file in the disk. So if that file is there, it's going to delete that file and it's going to recreate that file for you. So the contents in that file will be lost. So it's going to be an empty file. So if your file is not present in the disk, then this fopen is going to create that file and open it for you. So the next thing is, if you want to edit or append to that file, then you can open it with the mode A. So when you open this file with the mode A, if that file is there, then this fopen is going to open that file, and the contents of that file will not be lost. It will be present, and if you want, you can edit to that file. If your file is not there, then this fopen is going to create that file for you. So the next mode is R+. So if you use the mode as R+, then you can open that file for reading and writing purpose. So similar to R, if that file is not there, then it's going to return a null value. So if that file is present, then it's going to open that file for you. So the next one is W+. So similar to W, if that file is there, then the contents of that file will be lost, and you will be presented with an empty file, and you can edit, read and write from that file using this W+. So the last one is called A+. So if you use this mode as A+, then if your file is present in a disk, then it's going to open that file for you for reading and writing. And the contents of that file will not be lost, and it will be there, and you can edit to that file. So if your file is not present in a disk, then that file is going to be created and open for you. So this is about the normal file. So then if you want to work with a binary file, then you have to suffix it with a B here. That's for indicating that, okay, I'm working with a binary file. It's going to be RB, WB, AB, then R plus B, W plus B, and A plus B. So the next thing is, when we work with a file, we have to remember a lot of things. For example, the file name, the mode at which we have opened the file, then we have to remember last byte or last word which is read from the file, last byte or last word which is written to the file, and many things. So for that purpose, this stdio.h header file provides a structure for us, and the structure is called file. So when we use this fopen function to open a file with a specific mode, if that file is present in the disk, then this fopen is going to return the address to this structured file. So that structure is going to contain all the information about that file. Since this fopen is going to return the address of the structure of type file, we need a pointer of type file. It's going to be star. Let's call it f pointer. So now I'm going to delete all these things. In this tutorial, for the demonstration purpose, we're just going to create a text file. So to create a file, we have to open it first. It's going to be fopen. Then the file name, we call it as anil.txt, and the mode. So since we are running this program first time, the file will not be there. So that's why we want to create that file. That's why I'm going to specify this mode as W. So then this fopen is going to return the address of the structure which contains all the information about this file. That's why we have to assign it with this pointer, f pointer. That's why I'm going to write f pointer equal to fopen of anil.txt and W. So if this f pointer is contains some value or some address, then we can say that that file which we specified here is opened successfully. So if this f pointer contains a null value, then we can say that this fopen unable to open the file. So we can test that by using if condition. If f pointer equal to null, then we can say that printf unable to create the file. And else, that means this f pointer contains the address of the structure, and we can say that file opened successfully. So now, the last thing we have to do is, when we open that file, we have to close it. That's why here we can close it. It's going to be f close, the function name. Then we have to pass the pointer. It's going to be f pointer. So this is it. The next thing I want to explain here is, this files.c is present in my desktop. So when I compile this program, files.exe will be created at the desktop only. So when we run our program, that is when we run our files.exe, this .txt file will be created at the location where that file.exe is present. In this case, that files.exe is present in my desktop. That's why this anil.txt is going to be created in the desktop. So save it, compile it, and run it. So as you can see here, file opened successfully. That means that this fopen function created a file for us successfully. So now I'm going to minimize it and open up my desktop. So this is my desktop. As you can see here, my files.c and files.exe is present in my desktop. That's why this anil.txt is created in the desktop. And I'm going to open it. So as you can see here, it's an empty file. Here, another thing we want to do is we're going to delete this file now. Now anil.txt is not present, and for a demonstration purpose, we're going to make it R. Now we are opening the file with a mode R. So when we use this mode R, if that file is present, then only this f pointer is going to return the structure address. So now that file is not present. We have deleted that file. That's why this fopen is going to return a null value. That's why we will get unable to create the file. So we're going to save it, compile it, and run it. So as you can see here, unable to create the file. So similarly, we're going to change it into A, save it. So now, this file will be created for us, similar to W, save it, compile it, and run it. So as you can see, file opened successfully. I'm going to close it, and I'm going to open up my desktop. So as you can see here, this anil.txt is present. So I'm going to open it. So this is it. This is about the files. You can see in the next tutorial, we're going to see some more information about the files, like how we can edit some contents to that file and how we can read from that file. So thanks for watching, and don't forget to subscribe. Hi, this is Anil with a video tutorial for the Learning Lad on C programming. In this video tutorial, we're going to see how we can write character to a file. And also we can see how we can use the f_putc function to write character to the file. So before beginning, I want to explain something about this fopen function. So here, in the place of this file name, you can pass this path also. So but make sure that the path should exist. If the path is not existing, then this fopen function is going to return the null character, so that you get unable to create or open the file. So now we're going to begin with our f_putc function, or we're going to see how we can write a character to a file. This f_putc is going to print or write the character to the file. So as a parameter to this f_putc function, we have to first specify the character that we want to write. Then we have to pass the file pointer. These are the two parameters required for this f_putc function. So now let's see how we can use this f_putc function and write to the file. So here in this tutorial, we're going to first create some characters, and we're going to store it in a character array. For that purpose, we are using a character array. Let's call it data. Then declare the size 25, and we're going to assign it with the learning lad. So this is it. Now, this data array contains learning lad. This data array 0th position contains the character L, and the first position contains the character E, and second position contains the character A. Similarly, each position contains each character. So we're going to write each character to the file. So next thing is we are using a for loop to loop through this character or this data array. For that purpose, we need to know the length of this data array. We can get the length of the character array or a string by using strlen function or the string length function. So we're going to declare a variable. Let's call it length, and I'm going to assign it string length of the character array. It's going to be data. So now this length variable contains the length of the string learning lad. So by using this length, we can use a for loop to loop over this character array. So the last thing we need is a counter variable for the for loop. It's going to be counter. That's it. Now we're going to open a file called anil.txt in the write mode. That's because we want to write something to the file. And also, that file will be an empty file. So this f pointer is the pointer returned by this fopen function if we can open this file anil.txt. So here we're checking whether that file opens successfully or not. If that file not opened successfully, then we are printing unable to create or open the file. Else, if that file has opened successfully, then we want to write some characters to the file. So for that purpose, we're going to use for loop here in the else part. Then first we need to initialize our for loop. It's going to be counter equal to 0. Then we need to write a test condition. Counter is less than length. Then we need to implement our counter variable. It's going to be counter plus plus. So here within this for loop, we want to write to the file character by character. So we can use this f_putc function. Next, we have to specify the character we are writing. That character is present in the data array at the position specifying the counter variable here. So when this counter becomes 0, we are writing the character L. When this counter becomes 1, we are writing the character E. When this counter becomes 2, we are writing the character A. Similarly, we are writing all the characters until we encounter this D for the last character. So next we have to pass the file pointer. So the file pointer is this one, the pointer. I'm gonna copy this and paste it here. So just for our information purpose, we are gonna add a printf statement here. Actually, this printf statement has nothing to do with our writing to this file. So we're gonna say writing the character %c, then a new line. Then we have to specify which character we are writing right now. It's gonna be present in the data array and the counter. So here, by using this for loop, we are looping through this character array or the string learning, then a space, then lad. So we are writing each character at a time here by using this f_putc function. So I'm gonna save it, compile it, and and run it. So as you can see here, writing the character L, then E-A-R-N-I-N-G, then the space, that's because we have a space here, then L-A-D. That's it, it has successfully written all this contents to the file. Then it says data written to the file successfully. Open up this anil.txt, which is the file we have written right now. So as you can see here, learning lad. So I'm gonna close it and close this one also. Now we're gonna change this string. Let's say Anil Shetty rocks, and I'm gonna save it, compare it again and run it. So as you can see here, Anil, then a space, then SHETTY, Shetty, then a space, then rocks, and it says data written to the file successfully. Let's see whether it has written successfully or not. I'm gonna open up anil.txt. As you can see here, Anil Shetty rocks, and the previous content learning lad has been deleted. That's because we are opening this file using the mode W. So now we're going to make this mode as A. That means we are opening this anil.txt in appending mode. So whatever we write now to that file, that will be appended to that file. So you're going to say, okay, the same thing, Anil Shetty rocks, save it and compile it and run it. So it says the data written to the file successfully. We're going to close it and I'm going to open up anil.txt. So as you can see here, Anil Shetty rocks, which is from our previous run, and now it has Anil Shetty rocks. Because we are using this mode as A, our contents are concatenated to the contents of the file.